When we're using our limits can teach us about continuity. Continuity is just trying to determine if a function is continuous. Think about drawing a graph, and are you able to keep your pencil down the entire time? Okay, from start to end, you can keep your pencil touching the paper. That is a continuous function, meaning there's no gaps, there's no jumps, there's no holes, no asymptotes, nothing like that causing any discontinuities. So what we're going to look at right now is the definition of a continuity to determine if a function is continuous or not. Okay. Excuse me. This first example I have written up here, we can clearly see that there's a hole in the graph. Okay. So a way that we can show this with our limits is there's a couple different ways that we could talk about it. This limit exists. The left side and the right side limit approach the same value. So I know the limit as x approaches c from the left is equal to the limit as x approaches c from the right. Those are the same values. The problem is my limit does not equal the y value, because in this case the y value isn't even defined. Okay, but let's say it is. Let's say my y value is defined, but it's somewhere other than the limit. Okay, so we can prove that there's a discontinuity here, a hole in the graph, by saying, well, my left side and my right side limit are the same, but they do not equal the y value. Meaning if I plug c in, this y value does not equal my limit. Okay, does that make sense? We could write that as 1. The limit as x approaches c, right side and left side of f of x, does not equal f of c. That's the definition of a discontinuity with a hole. Okay, if the right side and the left side limit are the same, the limit exists. But if the limit doesn't equal the y value, we have a discontinuity. Okay? This is called a removable discontinuity, because I could come in and I could define my function to have this point, and now the gap is gone, that hole is gone, it's removable. Okay? So this is an example of a removable discontinuity. All right, here, with this graph, we can see this asymptote. This is an asymptotic discontinuity, okay? We have an asymptote. There's clearly a gap in our graph here. With this one, the limit as x approaches c from the left, well, it's going to infinity. It's going up forever and always. It's approaching infinity, okay? The limit as x approaches c from the right is going to negative infinity. So we're actually seeing our graphs converge. Whee! One's going to infinity, one's going to negative infinity. That's an asymptote discontinuity, or asymptotic, whatever word we want to use. Okay? And here, our f of c is undefined. So we'll just say that's undefined. There is no value here because we have an asymptote. That could be dividing by 0, or mostly that's dividing by 0. Okay? This is another discontinuity. Okay? Over here, we have a new discontinuity. Here we see a gap, literally a jump in the graph. So this is a jump discontinuity. In this case, the limit as x approaches c does not exist. The reason that that limit doesn't exist is because my left side and my right side limit are approaching different values. Okay? So my left side and my right side limit aren't equal, so the limit itself doesn't exist. If the limit doesn't exist, then our function is not continuous. Okay? The only way our function can be continuous is if our limit exists and our limit equals our y value. And that's what we have down here, okay? So here, my left side, the limit as x approaches c from the left, is equal to the limit as x approaches c from the right, and these limits equal the y value. If my left side and my right side limit are equal, the limit exists. If the limit exists and it's equal to my y value, our function is continuous. So the definition of continuity is the limit equals the y value. Okay? This is our definition of continuity. Okay. We can have discontinuities outside of a function's domain, and we can still work with that. So I want you to try the first part of our homework, see how you're doing with continuity. I'm going to get us another video about the intermediate value theorem, so look for that, and good luck. Email me if you have questions.